Ferme la porte, s'il te plaît. Donc là, on imagine qu'il y a 200 personnes qui nous regardent. Et eux voient l'écran, voient ça en fait. Il nous dit quand c'est OK?
C'est OK quand vous êtes prêts.
Ouais, ça y est, on est prêt.
Carrément.
Donc ça enregistre. Well, hello, good morning. We are live from CIGRE 2024. I'm François Flech, Head of Global Marketing at PcVue, and this is Vincent Renaud. Vincent, if you want to introduce yourself.
Good afternoon. Thank you everybody to be here. My name is Vincent. I'm from PcVue Spain.
So today we're gonna introduce our real-time control for a renewable energy system. So we'll introduce many references that we have and the way we implement PcVue for control center and especially for renewables. So brief overview, and we'll explain the challenges about the control center, some technical features, and then the success stories. So to start with PcVue, so who we are and what we do. So we are a software editor dedicated for monitoring and control any kind of connected system. So basically the platform collect any kind of data, connect any kind of systems and collect any kind of data, and then transform those raw data to information with many data processing. We have an interface for displaying and controlling all the system, and also capabilities for archiving all the data. And we can deploy the platform in many ways, from 1 station to 100 stations, as we're going to see during this presentation. We do work with 500 plus system integrators who know very well our platform and can customize the platform to fit the end user needs. And we have 40 years of experience in many vertical markets, and we do have subsidiaries worldwide with the focus in mind, which is be close to our users physically, but also culturally. So that's very important for us to be able to serve our users the best we can with the best practices, local practices we can. So as I said, we have 16 international branches. There's around 160 people in the group, in our group, and we do have more than 40 years experience in this area. And here you have some of our users focused on power. So as you can see, there's a major player in the power and energy world. We're gonna focus, and Vincent will present especially Iberdrola and all the subsidiary of Iberdrola worldwide, but also Siemens Gamesa and all others. So if you have any question about all of those projects, you can message us after the live, no problem. So a quick overview of the PcVue platform. So the PcVue platform, as I mentioned, is dedicated to monitor and control any kind of system. This is a very intuitive platform in terms of configuration, and it's really a main point regarding our platform. We have an advanced configuration environment, but almost everything is done by configuration and no code. So obviously you can also use code for very specific needs, but main configuration is done with a low code and no code. Then we connect any kind of system. As I said, we do have 200 plus drivers built in, so no need to use third-party software. In the power, for example, we'll see that we have all the IECs, DNP3, and ICCP, and so on. All is built in. Then the platform allows also to display all the assets and to animate for controlling and analyzing all the data with specifically an alarm and event management, which is also built in. So you can have the sequence of event. The deployment is also very important for us. So you can deploy from one station to 100 stations. And the point is that this is scalable, means that you can start with few stations and then make the system grow with many stations, with no need to redo and to redevelop everything each time. So this is cost effective, especially for long term. And many data processing features that we're gonna detail later. So the value proposition is that the platform is an open platform and it's very modular. It means that you can really customize and adapt the features and the way you organize all the project depending on your need. If you have very similar project like we have in power automation, you can develop some templates that you can reuse for many similar projects. So it's really cost and time effective. Also, everything is done with an object-based. So once again, you can have some templates and you can instantiate those templates. So when you have a very huge project, it's really, I would say, easy, even if we know that nothing is really easy, but it's very convenient to use a template. And as I said before, a bunch of built-in data acquisition drivers. The point on that is that those drivers are built in, so we have tested it. We did qualification for all of those drivers. So no need for you when you install those drivers to redo all these tests. Some of the drivers are also certified. So you're sure that there's no issue using them with PcVue. Also, we are an independent provider. It means that we are not linked with any manufacturers or any other players. Means that we can offer, we can work with many manufacturers. So we are agnostic and open. It means that we are able also to add technologies or features in the platform. Local technical support. We do have technical support locally, worldwide. So if you have any issue, we have teams just to support you in a good timing, and some people to accompany you. And the last point is really important, is that we work on installation which run not for 1 or 2 years, but from 10, 20 or 30 years. So obviously across the time, technology evolves, operating systems evolves, and it's very important to have a platform that evolves with old technology, and each version of PcVue is compatible with the previous one. It means that when there's some evolution of the version, there's no need to redo the project. So there's a seamless backward compatibility, which is really important in terms of sustainability of your installation. So now I'm gonna let the mic to Vincent to introduce challenges specifically for control center. We are here in the CIGRE, so we focus on power automation. And today the topic is the control center. So Vincent, I let you introduce.
Thank you, François. So when we talk about control centers for generation assets, for sure the criticity, there is a high degree of criticity. You cannot build a control center inside a building that is rented. You need to focus on the power supply of this building. It has to be a very, very high priority, not only for these leaders that companies that we saw before, but also for a country or a part of a country. So this is the points that are critical for the end users. We wanted to share our experience and to tell how we deal with this kind of challenge. It's an application that is really big, so it's a use of our product that is very special. And on the SCADA, as we are SCADA provider, what is critical for us is, of course, data acquisition, how to treat, how to process all of this data, and the cybersecurity issues that are very important also. A control center for generation assets needs to be connected to get data from the field in real time. So those data are coming from every generation set. So we'll see on the following slide, the generation set can be either wind farms, solar. We'll see there is some different sets from different providers, from different brands. Yeah. So the system has to be connected. It has to work every day, 24 hours. So the system has to run well. Also, getting data from the field is not sufficient. The control center has to inform the national grid with the power production real time, and to get back at the same time the forecast power production from the national grid. So there is an exchange of data in real time with the national grid. There is inside of the control center a lot of calculations, treatments, alarm management, user management, screens, the ability to send comments. So we'll dig a little bit on the specific needs. First about the generation sets. So we put one slide here just to explain how do we manage all of this? How do they manage this with our product? A generation set can be a wind turbine, onshore, offshore. It can be a solar plant. It can be hydroelectric plant. Then also battery energy storage system, and of course every time you have a substation next to the generation set, and weather stations almost all the time. So all of these sets are communicating with the control center. We put here two examples. I mean, one of the last sets that they add into the system in Europe, at least, from a very big customer. We have the example with the wind farm in Saint-Brieuc. So you can see the figures. So it's not it's a big set. There are a big amount of data. more than 100,000 information in real time. And the same from the solar plant. So it's not a small set again, and the system needs to get at least to be able to get all of these data from the local generation set.
And if I can add something here, is that basically there's more and more systems connected to the control center, heterogeneous systems, and those systems generate more and more data, more and more raw data, massive amount of data, basically. And there's really a need for centralization of all those raw data from wind turbine, from solar, from battery energy storage, and from any kind of various system. So there's a need to aggregate and to collect different kind of source of data, and then to convert those raw data into information. But as we will see, you have different kind of information, the field information and the control center information. And sometimes there's no need to have every data on the control center level. So there's a need to filter in a smart way all those data and provide some data to the field and provide some other data to the upper level. And with the same platform. That's the point also, to have not many platforms, which is really hard to maintain and to operate, but only one platform. So that's...
So the main challenges we had to face during these years, we need to say that it's been almost 20 years that our product is used in this kind of application, so in these conditions where the high availability of the data is really important. One of the first challenge is that you need to deal with very spread worldwide generation set. So you can have many solar plant or wind farms all over the world that you need to add into the control center, and of course in a reduced time. This is very important. The ability for the system to communicate with any kind of brands. So there should be no issue about the brand. Of course, if you want to add a wind farm from a famous brand like Vestas or Siemens Gamesa into the control center, there should be no problem with that. Another point which is really important is the high growth, the expansion of the database of the control center. Of course, all of these customers that now are using our product in control center, they all begin like small, in small size, and they begin to grow. You need to, so they asked us to have a product that can adapt to this growth. So it's really important for cost, but also on the technical part, the ability to add some servers without stopping the operations. So this is another point. When you add servers all the time, you need to maintain. If there is some problem on the database or you need to modify some things, it should be easy to maintain, easy to retrieve some data we'll see just after in the following slides. So the maintenance all over the time is really important. Some control centers are running since more than 20 years now. And of course, the capacity of the system to manage this amount of data, at least it has to be the capacity to grow to several millions of data as real time. This is really important. When we talk about real-time database, so this is a critical point. The ability to add any kind of a set in a reduced time and to organize it. So most of the time we can see that the database is organized through geographical zones. so it's easy to maintain. So there is a study to see how to manage this database, of course with oriented object and the structure of the database in PcVue. It helps a lot to maintain easily this kind of application. There are a control center in operation, generates a lot of alarms all the time, every second. So there is huge amount of alarms every day. So our customers are also challenging us. They take two HMI, two screens, and they will compare if the amount 1,000 alarms per second is, you can see it at the same time on the same screen. So this is kind of challenge that they are doing with us since 15 years now. So the high availability of the alarms is really important, the alarm management. To store the data is also critical. So every control center needs to store data, and we managed it by short-term, mid-term, and long-term. So for long-term, of course, there is already in the market some products, historian software that can deal with this. You can use PcVue for short and mid-term data. So this is available when the control center has a size that is quite big, 1 million tags or more. You can use PcVue also to archive long-term. Reporting functions are always needed, so this is a basic. And also one of the critical and that evolves a lot technical point is the communication with the national grid. So this is really important. It's almost every time different from several countries. So, some countries have different specifications than others, but of course we were challenged for our product to be able to communicate in a secured way with each national grid from each country that we have been asked for. So let's dig more on the technical features. So as I said, the system has to run properly with a high availability of data and big amount of data. So what we have done since today is an architecture composed of 3 levels based on the classical client-server architecture on TCP/IP wide area network, but it works also with fiber, satellite. So 3 levels. The first one is the local asset. So having a SCADA system to monitor and control this asset. So with the acquisition of the data from the field. And then this level 1 will communicate with the level 2. Not all the data, but it has to have the capacity to serve all of this, the amount of data through what we call front-end servers, level 2. So these front ends have very high availability of data. They are all redundant. We will see after. There is a treatment of the data at this stage, storage, reporting, and then you have level 3, which is the dispatching center. So the front ends needs to be able to communicate some of the data to the national grid in a secure way. So we will focus on each of the levels. So the level 1 is the local asset. Of course, the SCADA system needs to communicate with the equipments. So it can be a PLC, a controller, a switch, IoT, why not, sometimes. So the system has to be able to communicate with these equipments very stable in an industrial standard protocol. So they use the native built-in protocol inside our product. So it can be the IEC 61850, mainly for substations. It can be IEC 104, 101, DNP3, depending on the countries, OPC sometimes. And then makes the data available for level 2. So for this, we have a special protocol, which is inside PcVue product. So it's mainly a communication between two PcVue stations, but we can use also some industrial standard protocol. Level 2 is what we call the front ends. This one is very scalable. So they usually begin with 2 pair of redundant servers that we call front end. So they will get data from the level 1. You can also deploy some servers to archive. And these front ends are designated to be to have a real-time database by zone, geographical zones, and they will be able to manage all the treatment of the data. All of this data needs to be visualized. Each control center has big screens. It has to be a wall screen very big on a special room, control room. So for this, there is a challenge because you can have an HMI. It's really hard to have an HMI that can load the whole amount of the data of the control center. So we're talking about 2-3 million tags. So it's really hard. But in PcVue, we have one product that has been developed for this kind of application. So it is called FrontView. So FrontView will subscribe on only the data that are visualizing in their screen. Meaning, if you open FrontView, you have a screen which is called a mimic with the real-time data. And all this data that you see on the screen, FrontView will subscribe and will know in which front end are stored this data. So it's really fast, really efficient for operation. We can have also some web visualization, so in whatever the navigator. So you can open to have some local visualization, some sets. Level 3 is the dispatch center. So it is a really critical point. It evolves a lot. In Spain, for example, it has to be through a special protocol that is called ICCP, Inter Control Center Protocol. And it has to be secured. So it's a new version that is available since December. So every year it evolves. So you need to have every time the last protocol that is homologated by the national grid of the country. So this is really important. PcVue has this protocol ICCP built inside the product. So this is really important too, because there is no need to add a gateway between PcVue and the national grid. So this is, and what I said, yes, there is a bidirectional communication between the control center for generation assets and the national grid. So the control center will provide the real-time production of all the assets, and will get, at the same time, the forecast from the national grid. With the forecast from the national grid, there is a special algorithm that is developed and is communicating together with the SCADA, and will manage the forecast from the national grid and dispatch this amount of power that has to be generated for tomorrow, will dispatch to each asset. So if the national grid says we need to produce for tomorrow X gigawatt of power, the control center will dispatch this command, let's say, to all the assets. So this is the overall view of the architecture. We can say that the level 1, it is not mandatory to have a PcVue at this level. So of course you can install a PcVue like Edge node, and it will easily integrate inside the system, but you can maybe, most of the time, a set has already a SCADA system. So if it is able to communicate through a standard industrial protocol, so it's possible to communicate directly with the front ends. So this is also important. The ability to the system, PcVue, the openness of the system allows you to communicate with third parties SCADA system.
So as an example of all what we just described, I'm gonna focus on specific, success stories that we have. And Iberdrola is one of a big one, I would say. So I don't know if you want to introduce Iberdrola, maybe.
Yes, Iberdrola is one of the largest provider of power, not only wind but renewable energy power in the world. So in Europe, I think they are the first. So it's a big amount of money invested in this kind of assets. They are building every day many assets. So we can see it because they add in the control center all this kind of assets. So it's a really big machine. The forecasts are huge. So they challenge us. It's every time bigger. So we need to have the ability, technical features that I presented before, but also an organization that allow them to add all of these assets done by several providers worldwide. So it's a very big leader.
Yeah, and as we can see, the forecast 60 gigawatt by 2025 from 44. So it's a big trend, and yeah, there's need for a very efficient monitoring system at a large scale, and sustainable system as well, with high availability to ensure the continuity of service. So that's why this example is really interesting. So you can see here on the screen one of the control center with the big screen where operators can see any wind turbine anywhere in the world from this control center, in Spain, but also in US, and basically wherever in the world. And the HMI that Vincent just described are just all the stations that we can see here. So it's possible to filter any kind of data from any wind turbine and visualize it on this screen. So for Spain, there's more than 300 assets, 10,000 turbines for 13 gigawatt, and it's about 3 million of tags. So 3 million of information exchange in real time. So that's huge, huge to handle, huge to maintain, and obviously, as Vincent said, this system evolves every day. So they add new turbines, they add new wind farms every day, and the system must be stable. Whatever they add must be stable, and that's the case. In US, they have a similar control center with a bit less wind turbines, with 4,000 turbines. But once again, there's a massive amount of data handled by the system in real time by this control center. There's also some control center in Scotland with Scottish Power, and as you can see, it's also a huge amount of assets and tags there. The very important point here is that basically Iberdrola duplicated the architecture to create and to design each control center. So when we talk about templates, when we talk about scalability, it's really here the point is that they have a template of control center and they can rebuild one and design a new one in the same way. Obviously, they didn't do it from scratch each time. I mean, they reuse some existing template and some existing architecture, and that's the point with PcVue. PcVue allows that. Another example in Brazil here, and so that was mainly focused on Iberdrola. There's also success story. Maybe if you want Vincent to talk about it.
So it's really hard to show some screens because they don't allow people to enter into their control centers. It's confidentiality is really high degree. So what you can see here is a public picture from them. So this customer, Total Energy, built also a control center here in France, in Montpellier, and they can visualize real time all their assets, mainly wind farms, but they have also PV plants, maybe hydro, I guess. So it's more than 1 gigawatt, 400,000 tags, which is quite big, and it's still growing. Another control center made for Siemens Gamesa for their turbines, because it's a turbine manufacturer. So around 5 million tags, 60 gigas under control. They have also the thin client front view, some protocols that are very dedicated for them. Another control center is the company FEPSA. So here it's not necessarily a renewable asset, but I think it's also a good example of how open and how the system can adapt. Here it's more generation combined cycle generation set. And the system is stable, is working in Madrid, using almost all the electrical protocols, ICCP with the national grid, some thin clients, video wall, like it's quite the same architecture we saw before. And this is the our last slide. Just to resume the information we wanted to show you and to give to you. It is important from the SCADA provider to be independent. So, we have the direct relation with all of these end users. So this is really a comfortable relation for them, because they can directly speak with the software provider that are maintaining the source code of the product. So this is really important. It's been many years now we support this kind of application, more than 15 years. So you can imagine how many modifications have been done on the product, improvements, corrections on drivers,
New technologies as well.
New technologies implemented into the product. Many challenges every day by all of these companies. The architecture needs to be scalable. This is really important. They add almost every month at least, they add some redundant servers on the front ends, so it has to be smooth. High capacity of our product to handle from thousands of data to millions of data. Open system to communicate with all of these different brands. We saw it on the wind farms, turbine manufacturers, but also with some other systems, and a low-code configuration. So this is more the ability to scale and to split easily the database, real-time database in the control center.
Well, so we are now at the end of this session. If there's any question that you may have, feel free to. So we have a question. So okay, we cannot give you mics, but I can reformulate the question. So the question is, how long does it take to design a new asset? Like, I guess a new wind turbine or wind farm, maybe. That's So I don't know, Vincent, from your experience, is the
you can play. You can use the structure of PcVue software and a real-time database. So it's possible to modelize any kind of PLC controller made of several controllers. You can build a template of a wind turbine, and several wind turbines can make a template of wind farms, for example. So you can structure your database, modelize your database to generate, when you have a new assets to add, to generate this real-time database. So we have some customers that have built this kind of database generation. Some of our customers told us that they can really easily, in few days, they are able to add the new set into the control center, which is not so easy.
Yeah, but the important point is that PcVue is designed to be able to create some template that you can reuse and to faster the process of creating new assets, basically. So yeah, that's another question. So is it possible to have a labelized version of PcVue? So I guess you mean to have PcVue, but with another brand name. Understand? Yeah. So this is possible. We do have many versions of PcVue that are labelized. So the name is not PcVue, but it's basically PcVue platform. So it's something we can do, no problem. We have many customers doing that. So yeah, it's possible. Okay, if there's no more question, thank you very much, everyone, for being here today with us. And if you have any more questions, feel free to ask Vincent. Yeah, see you next time.
Thank you.